So, yeah, this is a challenging question. Let's try it. So, I gave it a try. Uh, at first, I thought that we could work with areas. So, like, I could represent everything in a square of one unit area. Then I would break it. So, break it according to the probability. Like, this will be half probability, this will be half probability of heads and tails. But then I realized that because they are taking alternative terms, it will get like really complicated because we won't be able to understand which head belong to which one. And yeah, so that was not a good idea. Then I thought, like, okay, you have two people, so maybe if we could use two dimensions, that would be really useful, and that kind of did work. So let me show you what I did. So at first I thought that for each head you could move either to x or either to y, 1 unit, and then when you will reach 2 unit you are done. And for each tail you could move like along the negative or negative x or negative y axis, 1 unit. But that isn't how it should be, because for each tail you aren't actually doing anything, you are just staying over here, right? So whenever you have a tail, it doesn't count as a decrease in anything, it just counts as doing nothing. You neither win nor do you lose, it just keeps on going, right? So okay, let's try to do it. So what am I doing here? Like, this thing, it represents the number of heads of A. So the number of heads that A would have gained till now, and this represents the number of heads of B, right? And for each point we will assign it a probability of like being there. So I know it sounds complicated, but once I start drawing it out you will understand what's happening. So first of all, you just start off at 0 comma 0. So there are no heads for A and no heads for B, so 0 comma 0. Then you have A's turn first of all. So when A will toss, it will be half probability of it becoming head, right? So the toss being head, and half probability of the toss being tails. So what we are going to do is we are going to split this point into half. Like, you can think of it like charge, maybe. Like, this point has a bit of charge, and all of these, like, they can, like, this can share charge with these points. And then this has, say, 1 unit charge, then it will share some stuff with this thing. Its probability, like, this has, right now it has probability 1. Then after the heads turn, the probability of, like, your number of heads for A being 1, that would be half, and the probability of your number of heads of A being 0, that would be half as well. So this would be 1 by 2 and 1 by 2. Okay, that's cool. Then there would be next chance would be B's turn, right? So for B's turn, you would split both of these into halves, because all of the cases of this point, like all the, like, half of the cases, the total cases that we are dealing with, call them n. Then this would be n upon 2 cases, this would be n upon 2 cases. So now half of that case as well, so this is going to be 1/4, and now that's also going to be 1/4. So why is this 1/4? Because, yeah, like, this had half n cases, but only half of them will give tails, and this is representing when there's no heads in A or B, and that can only happen like 1/4 n cases. Similarly for this thing, 1/4 1/4, like that. All right, cool. Now B's turn is over, we'll go back to A's turn. So now in the next A's turn, you will split this such that this becomes 1/8 1/8, and this will become 1/8 1/8 as well. Why did we do this? Because all of the cases over here, only those will actually give anything for 2 heads in A. And the thing is that these cases, these very leftwards cases, those will increase this. So 1/8 1/8, like that, and this is going to be 1/8 1/8 as well. So just notice the pattern, like we are always splitting each point's charge into half and then giving it, depending on if it's A's turn or B's turn, to the right or to the topmost point, sorry, to the immediate right or immediate top point. So basically we are kind of like shifting the whole thing. So all of this stuff, we just shift it so that it becomes over here, and then we add it to whatever that's, yeah, it's hard to describe. You just have to imagine what is happening. And that charge analogy, it like works really good because it helps us not think of it as number of cases all the time, not as like probabilities all the time, but instead as something that is divisible directly. Now in this case, the charge behaves very similarly to probability, because every section can be divided exactly into half and half, depending on whose turn is, into heads and tails, right? And those two sections, those will fall into some other section after division, of course. So yeah, we can just keep doing this. So right now it was A's turn, right? So it's 1/8. Next we'll be having B's turns. Now you know what to do, right? So just split all of the points in half, charges of the points in half, and then move up. So now this will be 1 upon 16. Instead of writing it like this, I'll write it as 2 upon 8 and 2 upon 8. Oops, 2 upon 8, 2 upon 8. Instead, in fact, I could also write it as 1 plus 1. You will say why I'm doing that. Okay, now we will move up. So now this will become 1 by 16 and 1 plus 1 upon 16. Yes, and this will become, let's see, this will become 1 by 16, this will become 1 by 16, but you went from this to this for half of the cases as well, so it should be 2 upon 16 right there. Similarly, this will become 1 upon 16 and this will become 2 upon 16, but then of course you went from this to this for half of the cases, so this should be this plus 2 upon 16 like that. Or I could write it as 1 plus 1 plus 2. And yeah, like these things, we don't care about them. They won't be shifted, because yeah, once you reach on the boundary of this these two lines, like once you reach these two lines, those cases are just halted, because they represent a game over scenario, that already now A has 2 heads, there's no need to play anymore, right? So yeah, it's just, we will count this as the winning probability, or a part of the winning probability, and it will keep on going. Okay, so now B's turn is over, we'll go back to A's turn. So now you can guess what's gonna happen, right? This goes to here, I mean it's half of that goes to here, so now this becomes 3 upon 16 becomes 32, and this becomes 32 as well, right? And this goes over here as well, so yeah, so the plus 3 upon 32, and this goes over here as well, so plus 1 plus 1 plus 2 upon 32. This is 32 as well, and this would also be 32. Oh, but it also goes over here, so the plus 2 right there. All right, so that is A's turn. Now let's go back to B's turn. So this will be getting very complicated if I draw it that small. Let's increase the size. Okay, cool. So now let's go back to B's turn. So you add it like that, it's going to be 2 upon 64 now, and this is going to be plus 1 plus 1 plus 2 plus 2 upon 64. This will be 2 upon 64, but this adds to that, so it's actually going to be 3 upon 64, right? Only half of this, right? Only half of this adds to that, the other half just remains over here, right? So this thing will be 64 like that. Oops. Right, no change in this 3, yeah, but this goes over here, so now it becomes 1 plus 1 plus 2 plus 2 plus 3 upon 64. So you see what's the pattern, right? Now I don't want to get this even more messy, so just going to look at what pattern is going on. So over here it's just 1 upon 8 plus 3 upon 32. You guess the next thing. After 2 turns there will, sorry, the next turn, no, this was B's turn. Wait a second. Yeah, were we doing B's turn or which turn? Is 3 upon 32, that must have been in the previous turn, right? So this is now the B's turn, right? And in the next turn this would be plus, oh no, this must have been 2 right there. Why did I write it as, yeah, so the thing is that maybe I did some mistake over here. Like, I probably, what I did is that I first shifted this to there and then this to there. That's not what I want to do. The existing things over there, you would split that into half, and then one half goes over here, one half stays over here too, one half goes over here, one half stays. So if this was 2 upon 64 at that point, then 2 upon 16 at that point, then 2 upon 32 would go over there, and 1 upon 32 would come over here, yes, and then it would become 3 upon 64. But you get the thing, right? It's like, yeah. And look, over here it's 2, it should also be 2, because over here there was no 3, now there's a 3, right, when you shifted it like that. And this 3 came from the previous term when you added half of this thing into that. So it's complicated, I know, but it's a way to do it. So notice the pattern: 1 by 8 plus 2 upon 32, 1 by 8 plus 1 plus 1 plus 2 upon 32, 1 by 16 plus 2 upon 64, 1 plus 1 upon 16, and then 1 plus 1 plus 2 plus 2 plus upon 64. You guess what the next thing is going to be? So every second term you add something to it, right? So now it's going to be 4 times this, which is 128, right? Yeah, and next it's going to be 3, because after B's turn it will just, yeah, do this thing. And over here too, it's after now that it's A's turn, it's going to be this added up like that. So 128, 1 plus 1 plus 2 plus 2 plus, okay, this is fine. And yeah, it just keeps on going. So plus dot 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 over there to plus dot dot dot, and so on. Yes, now notice the pattern over here. So let's do something for A. For A, what will this actual probability be? So it's like 1/8 plus 2 upon 32 and so on. So we can write this as half of summation of n upon 4 power n. It goes from 1 to infinity, I think, right? So half, because you start off at 1 upon 8. So that's like 1 upon 4, half of that. And 4 is 4 power 1. Okay, plus, so this is not all that we want, it's also this. This is a little more complicated. So 1 upon 8 plus 1 plus 1 upon 8, and all these things that are recurring is like 2 times. I think we should just take them out, and the other remaining stuff, that will be the same thing as this thing, right? So 1 upon 8 plus 2 upon 32. Oh, yes, 2 upon 32, 3 upon, that's actually going to be 2 times of this, so that half goes away. And the other stuff that we took away, so 1 plus 1 upon 32, that's just like 1 upon 16, right? So it's like 1 upon 16 plus this thing, it's going to be 1 plus 2 upon that upon 2. What's this? 128, which is 64, and so on. Next is going to be 1 plus 2 plus 3 upon 4 times of that, which would be 24, 256, so on, right? So what is this thing? It's like summation, actually no, you know what, 1/4 summation, so 4 power n, and then it's 1 plus 2 plus all the way till n. So the first thing was 1 upon 16, that's 1/4 of 1 upon 4. The next thing would be 1 plus 2 upon 64, that is 1/4 of 1 plus 2 upon 4 squared, and so on. And it goes from n equal to 1 to infinity. Okay, so thankfully we know a formula for this thing. It's just going to be n into n plus 1 upon 2, right? So upon 2, that goes over here, this becomes 1 by 8. Cool. And you can write this thing as, so n squared over here, like summation 1/8 summation of n squared upon 4 power n, 1 to infinity, and then this thing, so 1/8 plus 1, that is 9/8, summation from 1 to infinity of n upon 4 power n. Now we know a formula for both of these, so it's 1/8 of, so over here the value of a is 4. We actually derived this in the last video. If you don't know it, go watch that video, it's like very helpful. Okay, so for n squared it was a, which is 4 into a plus 1, which is 5 upon a minus 1 cubed, not square, cubed, because you have that 1 upon a everywhere. So if you do like dimensional analysis of this thing, considering n and a to be the same dimension, something like that, then it would make sense why there's some cube over here. And but yeah, the actual thing is just completely mathematical, that it is what it is. Fine. So this is just 3 cubed plus 9/8 of, what's this quantity? We also did this actually, so it is just a upon a minus 1 squared, if I remember correctly. Yeah, when it's nothing over here, just 1, then it's 1 upon a minus 1. When there is n, it's a upon a minus 1 squared. So a is 4 upon a minus 1 is just 3, that thing squared. Oh, this cancels, very nice. This is just 1 upon 2. This thing is, oh, this thing is like 20 upon, okay, 20 upon 8, that is 5 upon 2. Okay, 5 upon 2 into 27, so 5 upon 54 plus 1 upon 2, so multiply by 27 over there as well, so 27 upon 4, that's going to be 32 upon 54. So we got the value, so a is just 32 upon 54, like that. Yeah, because 5 and then 27, so it should work, I think. Okay, so now we can get rid of all of this. So this thing is just 16 upon 27. So the first value is 16 upon 27 for a. Alright, so I just say a, the probability of winning would be 16 upon 27, and from here I can guess that the other probability of like b winning, that would just be the 1 minus this quantity, because these things, they approach 0 as we go for more and more turns, right? But still, let's just find what the probability of b actually is. So for probability of b, it's 1 upon 16 plus 2 upon 64, so on, and then 1 plus 1. So this thing is like already nice, in a nice format. This thing is just, yeah, what is this? It's just like 1/4 summation from 1 to infinity of n upon 4 power n, and then plus, what's this thing? It's like 1 upon 8 plus 1 plus 2 upon 32, and so on. So 1 upon 2 summation from 1 all the way till n upon 4 power n. Yeah, this should make sense. And this thing is just n into n plus 1 upon 2, so we can write this thing as 1/4 and n into n plus 1. So we're going to do the same thing as before. So this is going to be 1/4 of 2 summation from 1 to infinity of n upon 4 power n plus, right, because 2 of course, and then summation of n squared upon 4 power n 1 to infinity. Hey, we already got that this thing is going to be 20 upon 27, right? Yeah, 20 upon, yes, 20 upon 27. And this thing is just a, which is 4 upon 3 squared, so 4 upon 9. 2 times of that, that's going to be 8 upon 9. So this will be 2 upon 9 plus 5 upon 27, so that is 3 times of that is 6 plus 5, right? It's 11 upon 27. So does this add up with that? Yes, it does. I mean 27 upon 27, that's just 1. So p is 11 upon 27. So what's the probability of a winning? Actually, we already got it, right? It's just 16 upon 27, and for b winning it would be 11 upon 27. So yeah, that's it. We actually did it. It was complicated, you know, like all of this, it was very hard to imagine, like 2 dimensions. Come on, think about it. Normally we just deal with areas and lengths of lines and things like that. Over here it's not even actually 2 dimensions, it's like 3 dimensions, because you have the probability as a third. So it's like a temperature graph, if you have seen that. It's something like that, or a scalar graph. Yeah, these are scalars. and it's even more complicated because you have to distribute it all the time. But yeah, it is possible to solve these kind of things. I mean, I want to generalize this so bad, but I don't think it will actually do any good, because even if I generalize this, the formula that I will get, probably that's going to be even more complicated than actually doing this on hand. So I'll just leave it like that. 16 upon 27, 11 upon 27. Oh, and what do you want? If chance of winning of A is A upon B, so that's 16 upon 27. GCD of A and B equal to 1, of course, in prime, yeah, co-prime numbers. Then unit digit of A plus B, so 16 plus 27. The unit digit of that, so 7 plus 6 is 13, so 3 is the unit digit, hopefully. Hopefully. Not sure what the answer actually is, but yeah, I'm gonna go with 3. So I'll see you guys in the next video.